In Algebra 1, you learn three types of functions: linear functions, quadratic functions, and exponential functions. In this video, we're going to learn how to identify what kind of function you have given a graph, an equation, and a table. Let's check it out. If you're given a coordinate plane and your function is a straight line, that means it's linear. If your function looks like a U shape, this is called a parabola, and this is a quadratic function. If your function has a curve or part of it is pretty flat and then all of a sudden it gets steep, that is an exponential function. Now that we've compared what each function looks like on the coordinate plane, let's compare their equations. If your equation has an x that's not being squared, that is a linear function. Because every x value you're plugging into this equation is multiplying 3 and adding 7, that's going to create a constant increase, creating a straight line. If your equation has an x that's being squared, that's a quadratic equation. It forms the shape of a parabola because every x value you plug in is being squared. So whether you plug in a -3 or a +3, they're both going to be a +9. Now, if your x is the exponent, that is an exponential function. As you raise 2 to a higher power, it exponentially increases. Now, when we're given a table, we have to do a little more work to figure out what kind of function we have. We first need to see how the values are increasing. In this first table, all the y's are subtracting by 3 every time. When it's constantly adding or subtracting the same value, that is a linear function. Now, because these values are constantly going down by 3, it's going to be a straight line, but it's going to have a negative slope. Now, in the second table, if you notice, we have this 2 in the middle, and then we have 3 on either side, and we have 6 on either side. Because these values are the same for both the negative and positive x, it's going to look like this on the graph. So this is a quadratic function. Now, the vertex isn't always shown in the table, so this pattern isn't always visible. So there has to be another way to determine if it's a quadratic. When we calculate the differences here, we'll see that there isn't a set pattern just yet. However, when you find the differences of the differences, you'll see that they do match. So in a quadratic function, if the second differences are all equal, that's another way to determine it's a quadratic. Now in this third table, the pattern looks like each y value is multiplying by 2. Now anytime your y values are multiplying by either a whole number or a fraction, that means your function is exponential. And as you can see, as our x's increase, our y values are getting a lot larger, a lot quicker, again, causing this shape on the coordinate plane. Now I've added one more type of representation, and those are word problems. So in this first example, the keywords here are $650 every month. That is a constant amount. As long as it's constant, it is a linear function. In this next example, a ball is thrown into the air. Now, anytime something is thrown up and it comes back down, that is going to be a quadratic function. For most quadratics, you're given the function and you have to be able to use it to find either the vertex or the x-intercepts in context, which is usually the minimum or maximum height or when the object, in this case the ball, hits the ground. In this last example, the keywords here are depreciates 10% every year. When you're dealing with percentages, this is an exponential function. Now, if your Algebra 1 course has a cumulative final at the end of the year, this will be a great video to save to review with.